Good morning. We will start session 10 on chapter motion. So we continue with the numericals here, that is in text numericals. Question number 5. This is something what you have to do this in your graph sheet. So a driver of a car traveling at 52 km per hour. So I can consider this as speed of the car as 52 km per hour. Time is given in terms of seconds, children. So I'll convert this as 52 into 5 by 18. I'll get that in decimal. I'll get 14.44 meters per second. And time T1 is equal to, and he applies brakes uniformly in the opposite direction. The car stops in 5 seconds. The next one, another driver going at speed 2. Most of the books it is 3 km per hour. Very few textbooks or they consider that as 30. I go with 3 children here. So as per the book here, there are few quite mistakes in the textbooks given here. One textbook says something, another textbook reads something. So it is 3 km per hour. So this is nothing but 3 into 5 by 18. So again, when you calculate this, I think you will get up to 0.83 meters per second. And time 2 is, and applies brake slowly and stops in 10 seconds. Okay. On the same graph paper, plot the speed versus time graph of 2 cars. Which of the 2 cars travels farther after the brakes were applied? So, which car has travelled farther? To know that, we have to know what is area travelled. That is nothing but the area of the thing, distance, whatever is part is what. Let's just check. So, if I have to draw the graph here, speed versus time as they have mentioned. So, let's consider y-axis and let's consider this as x-axis. So, this is speed and this is time. Okay, so the points if you see here with respect to time, it is how much, children? 1, 2, we have till 10. So I'll consider this as 1. Time in terms of seconds. So 2, 3, 4, 5, 6, 7, 8, 9 and 10. X-axis. In y-axis, we have this till 14, right? So I think we can take 2, 4, 6, 8. 2, 4, 6, 8, 10, 12. I think I'll just shift this, or anyhow we know the value. I will write the values there. Okay, I just erase this much of part. Easy for me to proceed with the graph. So 12, 14, 16, and this is y-axis. So this is at respect to speed 1, this is speed 2, where time 2 is 10 seconds. Let's plot with that respect here. Time 1 is equal to, t1 is equal to 5 seconds. With respect to 5 seconds here for the first one, and this is 14.4. So it's just what you have to mark, 14. So if this is 14, this part is 16. So what we can consider here is 14 point, this is 14, this is 15, this is 16, this is 15, 14.1, 14.2, 14.3, 14.4, somewhere here it comes. Okay, and here at 5. That means this is the point where I have to draw. Be a bit careful in drawing here, because accurately to know will be sometimes less. So we got the graph. Let us draw a straight line with respect to this. Okay, we have drawn the first part. Let us name this as O and this point as A and this point as B. That is the first part. You can just shade it lightly, not too dark, so that you will not understand what you have marked only. This is the first portion, that much it is traveled. let's look at the second part. Now second part, it is what here? So this is 10 seconds and 0.83. 10 seconds will come here. 0.83 means children here. Now this is 1. Okay. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, it will come here. Very near to this. So approximately, let me take. It becomes very difficult here for me to draw. But I hope you all can draw it easily. Right? This comes as a triangle button. Be very sure in drawing this. This comes neatly, comes as a triangle. If you can't take it too long, take 2, 4, 6, 8. OAB is over, B is over there, O, C, D. So this I will color in this part. This is one triangle. OCD is another triangle. Okay. Is this very clear? Shall I erase this part? Okay, now the calculation begins. Distance traveled, because we can't use formula to calculate here. We have to use the graphical portion only to calculate. Main thing I forgot to tell you, that scale x-axis 1 unit is equal to 1 centimeter. Y-axis 1 unit is equal to 2 centimeter. Fine. Now what we will write? Distance traveled by car 1 before coming to rest is equal to area of triangle. What we can take here as area of triangle. This was car 1, right? Yeah. OAB. So it is nothing but half into base into height. So this is half. What is base here, children? Base here is 5. What is height? Perpendicular height 14.44, which approximately you will get the answer as here 36.1 meter. Okay. Similarly, the next one, distance traveled by car 2 before coming to rest is nothing but area of triangle OCD, which is half into base into height. Half base is 10, height is 0.8. What did we get there as an answer? 0.83. So see, plotting wise 1 or 2 points here and there it happens. Value wise we have it correctly. So this is 4.15 meter. Anything else they have asked in the question? They have just asked which of these 2 cars traveled farther after applied, which of the 2 cars traveled farther after the brakes were applied. This is what you can do this. So which travel? Actually this traveled more than this if you compare. The next one, figure, shows the distance time graph of 3 objects ABC. Study the graph and answer the following questions. Now for this graph, children, it is a bit complicated. What I can say here is, or we follow some different techniques here to solve. So it has to be done in the graph only. We understand the given graph in the form of a slope. Now what is a slope? Slope is something what we study in coordinate geometry in standard 10. It is something what we derive the graph when the slope is given. See, if this is the given thing, this is actually called as a slope. It is given always in the form of difference in y-axis upon x-axis. So here I just try to give you the formula and try to make you understand that by giving some point and values to these lines what are being drawn. I will just give the figure on the board. You can just copy it as it is. I want you to do as how I have done it here in the class, rather how I have given in the notes. In the notes I feel it is a bit complicated method. There are many methods for solving this. I feel which I will be doing it today will be the easiest one. Okay, the next sum, what I have done here is I have drawn it and I had marked all these axes, because when you see that in your textbook it's given in very small numbers and in the graphical portion, I think this will be very clear for you. I want you all to make a note like this only. So just give a brief explanation, x-axis and y-axis, where this is time in terms of hours, and this part is they have given this as distance in terms of kilometer. Always remember, the slope of a graph when we calculate, it is nothing but which is distance by time. What do we get in distance by time? We get that as speed. So we consider here as difference in y-axis divided by difference in x-axis. That is the slope formula. Just remember that much. Now I have drawn the same thing, but what I have done was, wherever the points, wherever they are meeting, coinciding, I have drawn perpendiculars with respect to them, so that accurately we can explain and write the readings. So along with that I have also written the coordinates. For example, now this coordinate is nothing but 0.7. This coordinate is 0, 1.1 approximately, right? This coordinate is yeah, this is correct. I'm sorry, this I wrote wrong. This is correct, children. This coordinate is 0.7 and 0. X-axis, how do we read them? Right? 1.1 and 0. Yeah, I wrote wrong in x-axis. So these are the coordinates. Y-axis coordinate, this point coordinate, this point coordinates I have written. Now let's see what have they asked here is, which of the three is traveling fastest. Now I can only tell you that which is traveling fastest after I do the calculation. We'll keep that as it is. Are all three ever at the same point on the road? No. They are simple, one word answer we can give. No, they are not on the same point on the road. One has started from here, one from here and one from here. No, they are not. How far has C travelled when B passes A? How far has B travelled by the time it passes C? So for all this we need to calculate the speed. Let's calculate the speed how I have done. Speed of A is given by slope of Pn. So speed of A is given by slope of Pn, because that is the A line there. So Pn, how do we see? Difference in y-axis minus x-axis. That's what I have written here. I have given the answer also readily, children. See, one I will explain. 10 minus 6. Now, how it is 10 here is Pn when we consider this and this point you have to see. For this point it is 10 here. For this point it is 6 here. Y-axis, right? Divided upon x-axis. With respect to x-axis, what we have there? When we draw it to the down, that values we have written. Similarly, speed of B, OM, where is OM here, O is here, M is here. Speed of C is nothing but QM. So this point is Q and this point is M. How did I get these lines? Those lines I got that from ABC only. Quite difficult to understand and read from the graph, but this is how it can be solved easily. With that I got the speed of all the three A, B and C. Now if I say this is speed of A, speed of B, speed of C. According to you, the first one, which of three is traveling fast? B is traveling fast. And that is the answer for your first one. I hope the things are very clear. It has to be done in the graph, children. Okay. We'll quickly move to the next one. It's very simple. That is 7th one from the book, from the textbook. A ball is gently dropped from a height. Now acceleration is positive. So this is ground. So ball is gently dropped from a height. So 7th one, height is nothing but the distance displacement, that is 20 meter. If its velocity increases uniformly at the rate of a is equal to plus. Why? Because it is falling down. With what velocity will it strike the ground? U being 0, with what velocity it will strike the ground? So U is 0, V is equal to question mark. After what time it will strike the ground? T is equal to also question mark, right? Let's write the formula. What all we know? A is equal to V minus U by T. S is equal to UT plus half AT square. V square is equal to U square plus 2AS. I think we know U, we know A, we know S. I think I can use this formula to find V here. V square is equal to U square plus 2AS. 0 plus 2 into 10 into 20. V square is equal to 2 2s are 4, 400. So V is equal to root of 400. Always a square root will have always plus or minus value, children. Remember this. But here we cannot take velocity as negative. We have to consider V is equal to 20 meters per second. We study this in 10th standard. A square root will have two values always. We have done that by plotting the root numbers on the number line. See, negative of the root will not exist. A root can exist in, the square root of a given number exists in two values here. Okay, negative of a root will not exist. Next, what we have to find? Time. Which one do you want? Do you want that? A is equal to V minus U by T. So T is equal to V minus U by A. V is 20 minus 0. A is 10. So time is equal to 2 seconds. Very clear? And the next one. This is also again a graphical representation. But it is very simple. It is not as complicated as the previous one. Again, this has to be done in the graph only, children. So let's first draw the graph, how it is. So my graph might go a bit in a rough part. So let me first, okay, I'll first do the markings. That will be very easy for me. 0, 2, 4, 6, 8, 10. So this part is 6, 4, 2. This is speed and this is time. Okay. Now they have given this graph already, shading part, everything is being given. This is the speed time graph, but they haven't given shading here actually. I'll just explain this. Wait. This is the graph given. Okay. Find out how far the car travels in the first 4 seconds. That is why only this much. First 4 seconds we have to find. That's why I have shaded this part. The shade, the area on the graph that represents the distance traveled by this, we have done that. Which part of the graph represents the uniform motion of the car? Okay. Now the shaded area which is equal to this represents the distance traveled by the car. Distance traveled, which is this A part. Distance traveled by the car is equal to shaded region. Now the shaded region doesn't look like a triangle, but it is actually, if you go to see, if you have an imaginary part, it is actually a triangle. That is nothing but area of triangle, which is half into base into height. Half, base is 4, height till where it has come, till 6. So 2 ones are, 2 threes are, 4 threes are 12. It's given in meter or kilometer? Meter. This is the distance travelled by the car. Very clear in the first 4 seconds. Second part, which part of the graph represents the uniform motion of the car? From here it is a uniform motion, it is not changed at all. So the part of the graph in a different color what they have given, or that shows a straight linear portion, represents the uniform motion of the car. That is the part of the graph from what part the curve goes on. See here what happens, children, a bit difficult to analyze. First of all, they have to give a graph in a bit bigger size, in the zoom size. The marking should be very clear. So here what has happened, I have seen this, I have analyzed it, I have referred different books where it is given in a colored form. So I can easily give an answer here, same like the previous one also. From 6 seconds to further 10 seconds I can tell, but for you it is from 4 seconds. But what has happened, it has slightly curved and then gone in a straight line. So the part of the graph from time, that is from 6 seconds to 10 seconds, represents uniform motion. Okay, very clear. The next and the last question of this chapter. With that we complete the numericals of the chapter motion. Okay. An artificial satellite is moving in a circular orbit of 10th one it is of radius 42250 kilometer. So calculate its speed if it travels 24 hours to revolve round the earth. Now they have not given that here. It's given in kilometer, it's given in hours. We can as well do that in kilometer per hour only. Otherwise we have to again convert that in terms of meters per second and do it. So first write down whatever it is given. Calculate its speed if it takes 24 hours. Time is equal to 24 hours to revolve around the earth. Now first of all, it is moving in a circular orbit. This is the radius. Now time taken to run, what is it? Distance, what is it? Path traveled. Distance if I have to talk about, circumference, 2 pi r. Now we need to calculate its speed. So we get the answer in terms of meters per second. So this will be 42250 into 1000 meter. So this will be 24 into 3600 I can take seconds, because 1 hour is equal to, what you can consider here is 1 hour is equal to 3600 seconds. We know that. So 24 hours is equal to how many seconds? So that we can consider here. Distance anyway we know that it's a circumference of circle. Now write the formula. Speed is equal to distance by time. Distance is 2 pi r. Write that. Divided by time. Okay, we'll write time as this. So 2 into 22 by 7 into r is how much? 42250 into 1000. Time is 24 into 3600. 2 zeros, 2 zeros. So see again here the numbers are very big in calculation. So you know, let us try to first bring that in the lowest form. 2 12s are, 2 11s are, 2 1s are, 2 18s are. Then this will cancel. 2 2s are 4, 2 1s are 2, 2 1s are 2, 2 2s are 4, 2 5s are 10. Further you can't calculate again anything. So 2 6s are and 2 1s are. So that's, leave it as it is. Numerator multiply, or 2 3s are, 2 5s are. Do it again, 1 0 will go, but here the denominator will come less. 21 into 18 you keep in the denominator. Numerator will be 11 into 5 into 21125 divided by 18 into 3. So 4 5 6, no, it will not divide. Now you know simple how to divide this. Write the tables, start dividing. I will give you the answer directly, but that is how you go with the division children here. Write the tables of whatever you get that here. 11 into, simple, it is 55 into 21125, 18 3s is 54. Right, 54 ones are tables. 54 ones, 54 2s are, 3s are 4 5 6 7 8 9, and divide that. Multiply plus 55 into 21125 and then start dividing. I will give you an answer, but still you have to do the division process by yourself. 3073.74 approximately meters per second will be the answer. But if in case you get such big division, that's the only method to do that. Write the tables of that and start dividing. So with that we complete this chapter, that is numericals based on chapter